and talk about inscribed shapes. So who can remind us what it was that we learned about these inscribed angles versus central angles? You have to be careful. I think that's just a general rule for life. And don't forget your towel. Absolutely. So if we want to make a reminder of that up here, or on any of these really, the inscribed angle will be half the arc measure that is inscribed versus the central angle will be equivalent. We started yesterday talking about how we might be able to figure out all of the angles, because we could figure out this as well, right? Because that's the supplementary angle. So this would be 58 degrees. And we could find our third angle over here as well. So down here, take a moment, use this as your warm-up. Did you guys finish it? Okay. Oh, well, okay, it was on the way out. My brain is doing like 8 things at that point. All right, well, if we did that one, let's flip to the back. This is going to be a quick lesson, which is good because it's Friday and we only have like 20 minutes. Take a moment to think about these. And if this like comes to you really quickly, obviously move on to the next part after that. But how can we determine all of the missing angles in the inscribed shape? You could color code some things if you want, if you've got some highlighters. Oh. I think I got to the same O as you. Doesn't look very nice. Do you want to share that O with us? What? Breaking my heart. I mean, all I did was make it pretty. Funny enough, this is a 30, 60, 90. So good guess. Avi? Ooh, hold on. So you said that I don't have yellow as a pen. Yeah, but so I'm just going to write that in green up there. So Avi said that 60 would relate to the arc being 120. Okay. What'd you say after that? Okay. That is true, but I don't know how that helps. What is 180 degrees? Oh, so my blue arc is 180. Wait, if blue is 180, what's orange? Oh, because then this half would also be 180. So then this is 60. 180. Meaning this is 90. And this orange angle is... Can we make like a rule out of that? Like what big thing like was critical in, oh yeah, I know everything else now. Yeah, you got real excited about the diameter. So the rule that we can make is when we have an angle inscribed to the diameter, what is that angle going to be? 90. It has to be. So guys, the angle inscribed to the diameter will always be a right angle. So I didn't have notes space to fit that rule. Like I was going to take a screenshot and attach it there. But if you can't just remember that, you might write it down here. An inscribed angle that subtends the diameter will always be a right angle, because really this is an angle technically, right? That's 180 degrees. This arc has a measure of 180 degrees, meaning that this is 90 degrees. So our angle B down here would be 44, right? The complement of 46. What? Oh, here. You can fix that. Just do this. Sorry. Split this. This goes down here. These didn't have any written text with them. The written text goes to down here. You tell me. What does it need to be a diameter? Do we see the center of the circle? Is that line, is that chord, right? All we know it is a chord. Is that chord straight? Yes, because a chord has to be straight, because there is no name for a squiggly chord. Yes, actually. Lines that appear to be straight are assumed to be straight unless we're told otherwise. Now, we cannot assume angle measures, but a line that appears to be straight, at a certain point, mathematicians all agreed. They said, hey man, if you draw a line that looks straight, I'm going to assume you mean it's 180 degrees, and no playing tricks on me, right? No making it 179 degrees and being like, ha ha ha, I got you. Seriously, mathematicians agreed that a line that appears to be straight is straight unless notated otherwise. So if it's not straight, you've got to give an angle. And we see the center of the circle. Now, in con, it would probably actually say O is the center of the circle, meaning that AB is the... But I chopped that stuff off because I knew that we were going to talk about this together. Questions? Maybe till 32. All right, 10 minutes left. So you should be able to solve the other ABC on your own over here. Angle A up here would be how big? 53, because we know angle C is a right angle because it subtends the diameter. Down here, they go ahead and tell you AB is the diameter because it will be in a bit more formal. 1230. Yeah. Oh, snap. Okay, so we know that this is a right triangle. Why is it 10? Do you realize that you just said no to something that was true? What you said was true. I'm not saying that what you then said was not true, because what you said was also true. But be careful when you're like, no. That was kind of rude. Because he was like, the Pythagorean theorem. And you're like, no, it's the... But what he is thinking the same thing that you are. He just said it differently. It's a 3, 4, 5. But that comes from the Pythagorean theorem. Without the Pythagorean theorem, we wouldn't have the 3, 4, 5. So that's what he means. I really doubt that you did the math to do the Pythagorean theorem, right? Yeah, it's 3, 4, 5. It's 6, 8, 10, right? And this one is also a Pythagorean triple. You're correct. So I'm not typing answers into Khan, though. I get excited about a lot of math. You guys just didn't get me. You didn't get the full Phoenix experience, so I'm sorry. All right, so over here, what sort of special triangle is this? I mean, I don't care. Shout it out. We're not there yet. You're being rude. It is a right triangle. We know that because of the diameter. Do we not have this Pythagorean triple memorized? Yeah, it's 13, meaning that your radius will be 6.5. 5, 12, 13 is another Pythagorean triple. So is 7, 24, 25. That's just a fun one that we sometimes see. 7, 24, 25. So we also saw another rule in, I forget if it was on the front of this or, no, on the other worksheet that related these arcs and angles. They tell me arc FJ, right? Arc FJ is 84. Now the pain is that we don't have central angles here. I want you guys to take a minute, see if that's 84 and GH 76. How can we figure out HKJ? Whoa, take a minute on your own. So I don't want you to give it away before people get a chance to think. Let's go at least 2 minutes. I'm running out of time, but... If you want to do this problem, I will let you talk us through it, though. If you would like, not trying to force anyone into anything. Make sure that you're taking this opportunity to try this and take a risk on your own, because I'm here to help you. Here to catch you when you fall. What? Sorry, what? No, like if you trip, if you fall, if you like, I'm your safety net here. That's why it's called a risk. It helps you grow as a person. Here, Amar, I'll get you more comfortable with performing in front of people. Amar, in front of the whole class, can you tell me what else I can figure out based off this 84? Amar. So since the inscribed angle FJ comes from back here, if I wanted to color code, I could actually color code all of this. Can you tell me what angle G in here is going to be? How does the inscribed angle compare to the arc that is subtended? It is half of it. So remember, this angle right in there would be 42. please make sure that you're labeling that with us, because G subtends the arc that is 84, the angle is 42. Likewise, GH arc is subtended from angle F. So, Amar, can you tell me how F will compare to 76? Yeah, it's half of it, right? So it's 38. Crap. What can I do from there? We know what? No, you're right. Yeah, because we know the triangle angle sum theorem, right? So we can do 42 plus 38 and minus that from 180, which gets us, I'm not sure. Oh, that would make sense. Yeah, okay, so that's 100. Look, it's good to practice the tactile of typing things in. And then wait, how does angle K relate to angle K? They're vertical. Sorry, that's why we use 3-point angle notation, right? Because I can't say angle K. But yeah, they're both vertical to each other. And then we could also actually, just looking at, how this kind of snowballs out of control, we could then figure out that this angle is 80. Right? Because it's the complement, it's the supplement. Is it what? Did you get 100? Then yeah, you just took a different route. There are always multiple routes that we can take. So as long as that makes sense. Now your quick answer, because we have 2 minutes left for down here, what do we do? Same thing. So with inscribed shapes, let's just look at the middle one real quick with each other. This angle of 73, actually I should probably use highlighters, subtends this arc that includes arc DK. Right? This angle 85 subtends the arc that includes DK. Right? So DK is now a shared arc between those two. We can use some creative algebra to figure some things out. So this arc would be 146, right? This arc would be 160, 170. How many degrees does a quadrilateral have? 360. If I look at angle K, it subtends the other part of yellow and around to there. If I look at angle D, wait. Pink and green, pink and yellow, blue and yellow, green and blue. All of my arcs are subtended twice. I bet that's useful. I would bet that that is useful. But regretfully, I'm out of time. So I'm going to have to leave you hungry for more math until next week. Fine. Whatever. Do self-directed learning. See if I can. It's like that trick of like, what's it called? Reverse psychology. I'm like, I don't want you to move on in comp. No, but there are a lot of us that do still need to get the work done that is due next week, which I honestly could have probably made due. Hey, notice how like the teacher was making an announcement and then you just started talking? It obviously shows that you don't give a crap about what the teacher's saying. So, I'm just trying to make you guys more aware of the things that you do. That work that is due like next Wednesday should really be due like today or Monday, but I'm not going to change the due date because that would be rude. But we're done with all of that. Like, we've done it all in class, so please try to get it done over the weekend. I need to know if you're struggling. Because I need to know if I need to slow down and, like, go back, or if we can move forward. So please try, even though it says it's due Wednesday, please try to get that stuff done. Thank you very much. Now you can have whatever conversation you were wanting to. Gravity, that fickle gravity.